Welcome to the deep dive. This is where we take your sources, find the core insights, and basically get you up to speed fast.
Yeah, cut through the noise.
Exactly. So today we are diving into a really interesting discussion that's been happening in the AI community.
Right. It stems from some research Apple put out recently, and then almost immediately a critique popped up.
And we've got the materials here, papers, articles, all looking at how we figure out if AI can actually reason,
Mhm.
solve tricky problems.
We're drawing on several pieces, looking at the different angles on this.
So our mission for this deep dive is pretty straightforward. We want to unpack what Apple's research seemed to show initially and then really dig into the main arguments of this critique.
A critique that says, maybe, hold on, maybe the methodology had some issues.
Right. So by the end, you should have a solid grasp of this specific debate and maybe, a better sense of the bigger challenges in testing AI reasoning.
Okay, so let's set the stage first. Apple put out some research looking at how large language models, LLMs, handle classic logic puzzles.
LLMs, the tech behind things like ChatGPT and other chatbots.
Exactly, and they use puzzles like the Tower of Hanoi, river crossing tasks, standard tests for planning and logic.
Okay. And what was the headline finding from Apple based on what we're seeing?
Well, the summary suggests the main takeaway was that these models kind of hit a limit.
A limit.
Yeah, they showed significant limitations, sometimes described as collapsing, actually, when the puzzles got more complex.
Collapsing. Wow. So, they just couldn't handle it as the difficulty ramped up.
That seemed to be the implication, yeah, that maybe there are fundamental limits to their reasoning power when faced with harder versions of these tasks.
Okay, that sounds like a pretty big claim.
It is. And, research like this, especially on something as complex as AI reasoning, it always invites scrutiny. It's how the field moves forward.
Makes sense.
So, inevitably, a detailed critique surfaced, and it argues pretty strongly that, well, maybe these failures weren't purely about the AI's reasoning ability.
Ah. So not necessarily saying the AI can reason imperfectly, but saying the test itself might have been flawed.
That's the core of it. The critique suggests the problems might stem from how the tests were set up and, crucially, how the results were measured or evaluated.
Okay, questioning the yardstick, not just the thing being measured.
Precisely. And this critique highlights three main potential shortcomings in the methodology used, three areas where things might have gone wrong in assessing the models.
All right, let's get into those. This is where it gets really interesting. What's the first point the critique makes?
Okay, the first one is all about tokens and how limits on them might have been, well, misunderstood or misinterpreted.
Tokens. Those are like the pieces of words the AI uses to generate text, right?
Exactly. And the critique uses the Tower of Hanoi puzzle as a prime example here. Remember that one? Moving disks between pegs.
Oh, yeah, the one where the number of moves just explodes as you add more disks.
Right. It grows exponentially. For n disks, it takes 2 to the power of n minus 1 moves.
So 3 disks is 7 moves, 4 is 15, but 8 disks is what, 255 moves? Gets big really fast.
It's huge fast, and that's the key. The critique points out that for these larger versions, say 8 or more disks, the sheer number of moves you need to list for the full solution is incredibly long.
Okay.
And generating text costs tokens. The source material estimates that describing just one move in the Tower of Hanoi might take around, say, 10 tokens.
10 tokens per move. Okay, so for 8 disks, 255 moves times 10 tokens. That's over 2,500 tokens right there.
And for 9 disks, it's 511 moves, so over 5,000 tokens. 10 disks over 10,000 tokens.
Yeah, okay. I see the problem.
It gets much bigger. The critique argues that for 8+ disks, the total tokens needed just to write out the full step-by-step solution. Well, it massively exceeds the maximum output limits of many models.
Like Claude, which the source mentions has a limit around 128K tokens, but even smaller limits would kick in way before that for these puzzles.
Right. Even models with large context windows have output limits that can be much smaller, or just practical limits on generation length.
So the model might have actually, figured out the whole puzzle sequence in its head, but when it tried to list all 255 or 511 or 123 steps, it just stopped because it hit its output token limit.
That's exactly the argument. The critique suggests the model could have reasoned perfectly, found the correct sequence, but simply ran out of space, ran out of its token budget before it could print the whole thing.
And the evaluation just saw an incomplete answer and marked it down as a reasoning failure.
That's the critical implication. It looks like the model failed to reason because the complete output isn't there. but the underlying logic might have been totally sound right up until that output limit was hit.
So you're not actually testing reasoning in that case. You're testing its ability to produce super long text outputs.
Potentially, yes. You're measuring adherence to an output length requirement that might be impossible for the model rather than its core logical skill on that specific problem.
Okay, wow. That feels like a really significant potential issue. Penalizing an output limit and calling it a thinking error.
It's a major confounder, according to the critique.
So how would you even test it differently then, if you can't just ask for the full answer for complex cases?
Well, that's the challenge, isn't it? The critique doesn't necessarily prescribe the perfect solution, but it implies that just checking the final complete output is flawed for these long cases.
Right.
You might need tests that probe intermediate steps, maybe ask for a summary of the strategy, or check performance on smaller versions first. Simply demanding a multi-thousand token perfect sequence seems inherently biased by these output constraints.
Okay, so point one, output token limits might be masquerading as reasoning failures. What's the second major issue the critique brings up?
The second point shifts focus to the river crossing puzzle. Again, a classic logic task.
Like the farmer, wolf, goat, and cabbage, or missionaries and cannibals.
Exactly that kind of thing. Move people or items across a river with constraints on who can be left together, boat capacity, etc.
Got it. So what was the problem there?
The issue, according to the critique, was that the tests apparently included puzzle setups that were, well, mathematically impossible to solve.
Impossible, like literally no solution exists given the rules.
Precisely. The examples mentioned involve scenarios like having 6 or more pairs of actors needing to cross, where the boat capacity and the rules just made it impossible. No sequence of moves could ever work.
Okay, so if a model is genuinely reasoning, you'd kind of hope it would spot that, right? Say, hey, this can't be done.
You would think so. But here's the kicker, according to the critique.
Oh.
The evaluation system they used apparently penalized the models even when they correctly identified these puzzles as impossible.
Wait, what? They got marked wrong for being right.
That's what the critique alleges. If the model responded, this configuration is unsolvable under the given constraints, or maybe it tried a few things and then stopped, it was marked as failing the test.
That seems completely backwards. Surely identifying impossibility is a form of reasoning, a pretty important one.
It absolutely is. The critique argues this setup basically penalizes correct logical deduction. It means the test wasn't really measuring the ability to understand the puzzle's logic. It was measuring maybe adherence to outputting something that looked like a solution sequence, even when none existed.
Or just the willingness to keep banging its head against an impossible problem.
Kind of, yeah. It suggests a flaw in the test design itself for those specific cases. You're penalizing logical correctness because the evaluation expected a non-existent solution path.
Okay, that's a big one too. Testing reasoning should definitely reward figuring out something can't be solved.
Right. It raises serious questions about what the test was actually valuing.
All right, so we have token limits misinterpreted and penalizing models for identifying impossible puzzles. What's the third main point from the critique?
The third point zooms in on the evaluation script, so the actual automated code used to score the model's answers.
Okay, the program checking the work. What was wrong there?
The argument here is that these scripts basically had the same problem we discussed in point 1, but baked into the automation. They apparently didn't properly distinguish between a model making a genuine logical mistake versus just hitting a practical limit, like the output token cap.
So how did the script decide if an answer is right or wrong?
According to the critique, it primarily looked for one thing. Did the model output the full, complete step-by-step sequence of moves that matched a known correct solution?
So very black and white, all or nothing.
Screamingly, yes, based on the final output matching the expected full output.
So let's go back to that 10-disc Tower of Hanoi puzzle needing over 10,000 tokens. If the model correctly generated the first, say, 5,000 tokens worth of moves perfectly, but then hit its output limit and stopped,
the script would just see an incomplete answer. It doesn't match the full 10,000 plus token solution.
and mark it as wrong.
Exactly. The critique suggests the script didn't have the nuance to say, okay, this part looks correct, maybe it just couldn't finish. It just compared the output to the full target solution, saw a mismatch because it was incomplete, and scored it as a failure.
So the script itself was basically hard-coded to mistake an output limitation for a reasoning failure. Point 1 was how humans might misinterpret it, and point 3 is the automated system was designed to make that same mistake.
That's a great way to summarize it. The scoring mechanism didn't factor in the operational constraints of the models. It demanded a level of output completeness that might have been impossible for the models to provide, leading to those attempts being labeled as reasoning failures by the script.
Okay, so we've unpacked these 3 points: token limits, impossible puzzles, and the flawed scripts. Stepping back a bit, why does this matter to you, our listener? Why get into the weeds of AI puzzle tests?
Well, I think this whole discussion really shines a light on something fundamental, right? It shows just how challenging, how incredibly complex it is to accurately measure AI abilities, especially these higher level things like reasoning and problem solving.
It's definitely not as simple as just giving the AI an IQ test and getting a number.
Not at all. This specific debate really underscores how the design of the test, the tasks, the constraints like token limits, and crucially, the metrics and evaluation scripts, how all that can massively influence and potentially distort our perception of what these AI systems can actually do.
It makes you think whenever you hear AI fails at X or AI aces Y,
Yeah.
you really need to ask, okay, but how are they testing it?
Exactly. Was it a fair test? Was it really measuring reasoning, or was it measuring something else, like the ability to follow instructions precisely or generate really long text, or even spotting when the test itself included impossible tasks?
Right. This whole exchange, Apple's research and the critique, it serves as a really valuable case study.
It does. It shows how easy it might be to draw the wrong conclusions about AI performance if the evaluation isn't super careful about isolating the specific skill you want to measure and controlling for these other factors.
It pushes us to be much more critical about how we benchmark AI progress.
Definitely. We need to think really hard about what constitutes a truly fair and accurate test for something like reasoning.
Okay, so let's just quickly recap the critique's 3 core arguments again for everyone.
Sure. First was the misinterpretation of token budget limitations, particularly for puzzles needing very long outputs like the Tower of Hanoi. Hitting the limit looked like a reasoning failure.
Second was the inclusion of impossible puzzle cases in things like the river crossing test, and then penalizing models even when they correctly identified them as unsolvable.
And third, the evaluation scripts themselves were potentially flawed, conflating these practical output limits with genuine reasoning errors because they demanded a full, complete output regardless of model capacity.
Right, so this whole deep dive into the critique of these AI puzzle tests really leaves us with a pretty big question, doesn't it?
It does.
As AI gets more and more capable, how do we actually create tests that are, truly accurate and fair measures of reasoning? How do we make sure we're testing the logic, the understanding, and not just output length or instruction following?
What does a truly robust, unbiased test for AI reasoning even look like? That's something to really chew on. It's critical for figuring out where AI is truly headed.